All right, our last video for part C, going through 76 through 85, so two sets of questions. So, 76 through 80 starts is a waves question. It says a wave traveling through a uniform medium has an amplitude of 0.2 meters, a wavelength of 0.4 meters, and a frequency of 10 hertz. 76 through 77 says, on the grid in your answer booklet, please draw one complete cycle of this wave. Okay? So, we have, and it's very important to read the axis on this, okay? On the y-axis, we have particle displacement. Essentially, what that really means is amplitude. Okay? When we see the amplitude is 0.2 meters, this means 0.2 meters both above and below the equilibrium position. But we can't do anything with that. We can't start drawing until we know how to graph on the x-axis. So the high point should be at 0.2, the low point should be at negative 0.2. We can't do anything with that until we know how to draw in the position. Position is measured in meters, which means we need this is a spatial axis, okay? It has to do with distance, okay? They give us a wavelength and a frequency, okay? Don't get messed up in with the frequency, think that you're supposed to do something on the x-axis. If this was a time axis, absolutely the frequency would be very, very important. But as it is, this is an axis. That means we have to display some sort of distance on it. And that distance is going to be the wavelength. We know that this wave has a wavelength of 0.4 meters, so we should probably start and end this wave at 0.4 meters. Now remember, one full cycle of a wave means if we're starting here, we need to draw all of this. This is one full cycle. It's not just this, it's not this, okay? It has to go it's not this, I should say. It has to go all the way back to its initial position when the wave is, when you're tracing back in the same direction. One full cycle, okay? That's key. So, what that means is if we start here, we go up, down, and then back up, then at some point in the middle, we are crossing through the equilibrium position again, right here. So, I think drawing these dots kind of helps. We know that in the middle, between these two, the wave is going up to its highest point, and in between these two, it's going down to its lowest point, or vice versa. It doesn't really matter. As long as you somehow connect these points and it looks somewhat like a wave, you could even do straight line connections, but I think that's really ugly. It doesn't really matter as long as you get something that looks generally like this. You are given, on this question, 1 point for drawing with a correct amplitude, 1 point for drawing the correct wavelength. You only need one cycle of this wave, so we're done with that. 78 through 79, calculate the speed of the wave, okay? Wave speeds sometimes are measured in distance over time, but they don't have to be measured in distance over time. The wave unit, we really focus on describing waves in terms of their frequency and their wavelength. And if you multiply those two together, you get the velocity. And I spent some time in class trying to get you to think about this. Think about a water wave that has a certain length, and so many of those waves pass you in a certain amount of time. You can kind of get the idea that if you multiply those two together, you should get how fast the wave itself is moving. If you have a wave crest near you, the next wave crest is 5 meters away, and 2 waves are passing you per second. That means 2 5-meter waves are passing you every second. So that's 10 meters of distance in 1 second. The waves must be moving 10 meters per second as an example. We are given the frequency and the wavelength. We can very easily find the velocity. I saw very few people have trouble with this on the Regents. Frequency is 10 hertz. Wavelength is 0.4 meters. The velocity is 4 meters per second. Determine the period of this wave. Sometimes I still have people have problems with this. You're given the frequency. The frequency is defined as how many times something happens per second, okay? So if you are driving in a car, or if you ever see like RPMs, that's revolutions per minute, that's a type of frequency. We usually like to stick to something that happens once every second. If you see a wheel that's spinning 10 times per second, the frequency is 10 hertz. The period is how much time it takes for one of those cycles to happen. They are inverses of each other, and in the reference tables, the equation is given just like that. T equals 1 over F. So T equals 1 over 10 hertz. Remember, hertz is just inverse seconds. Period is measured in seconds. It's how much time it takes for something to happen. Therefore, the period must be 0.1 seconds. Okay, pretty straightforward. Our last question, 81 through 85, is a graphing question. It was actually one of the more frustrating graphing questions to grade. It's been a while since I've actually done this question. I can't remember how annoying it was to do. I don't think it was too much, but we'll let you be the judge of that. Okay. In an experiment, the potential difference applied across an unmarked resistor, meaning you don't know the resistance of it, was varied while the resistor was held at a constant temperature. The corresponding current through the resistor was measured. Here's the potential difference. The data collected appear in the table below. 81. Mark an appropriate scale on the axis labeled current A. This is barely a physics question, okay? The best way to do this, really, I typically, what I do is I count up how many boxes I am allowed. Let's see here, and there are some, actually, I'm not even going to count the boxes this time. I see that I'm allowed 1, 2, 3, 4, 5, 6 tick marks. So starting at 0, that means I have 5 bigger tick marks to work with. The highest current I'm going to get to is 0.0244, which is pretty close to 0.025, which can be evenly split into 5. It takes a little bit of reasoning, but at this point in the year, you should know how to label an axis, okay? There's many different ways to do this, as long as your axis is consistent. Please don't do what I've seen before, take this number, put it here, take this number, put it here. If you do that, you're changing the size of all the boxes from one section to the next, and that is not a good graph, okay? That is actually the absolute wrong way to do a graph. So, if I follow what I was just talking about a minute ago, I should be labeling like this, okay? I'm actually going to 0.0000, and you don't need all these zeros, but I'm going to fill them in anyway. 0.0050, 0.0100, 0.0150, 0.0200, and 0.0250. Hopefully I didn't lose anyone with all the zeros there. But that's really a point. I really shouldn't have to explain that one, okay? Do whatever makes you feel comfortable as long as you can fit all the data pretty much over the entire thing. Don't get super precise, okay? It's fine that the data does not end right on this line. That's probably better. And don't take too much time on it. Do it nice and quick, okay? Plotting the data points, very straightforward. You should also know how to do this given as many graphs as we've done throughout the year. You need to make sure that you are within, I think it was, 1/3 of the grid space. So if it was really supposed to be here, you can be up to here away. If you're more than, I really looked at it as half a grid space, okay? If you're clearly more than half a grid space away, I couldn't give you a point for that. So please take your time, double check your points when you're graphing this. So let's see, 1.5 and 0.0032, that goes, now I hope I don't mess up on camera, that seems like it would go here. 3 and 0.59, that's about here. 6 and 0.1024, that is right about here. 9, 0.0177, so 9, there's 8, okay, that goes about here, and 12, and okay, goes about there. Now, I believe those are all plotted correctly. It really should be very clear this is a linear graph. So when it says draw a line or curve of best fit, please don't draw a curve. Yes, this data is extremely linear. So let's put it a line of best fit right about here. Okay, it probably could have been shifted up a little bit. I am not a stickler for lines of best fit. That looks pretty good to me. Now, so there's 81 through 83. 84 through 85, using your graph, calculate the resistance of the resistor. You might be like, what the heck does that mean? Well, let's look at what we're graphing. We're graphing V versus I. So our slope the change in V over the change in I. Now, let's go back to Ohm's law for a second. We know Ohm's law is V equals IR. What do we get if we rearrange this? If we do V divided by I, we get R. The slope must be the resistance of this resistor. So all we need to do is find 2 points, plug the coordinates of those 2 points into the slope equation. We should have the resistance. That's actually really neat. Okay? The key here is the points have to be on the best fit line. Okay? So when I did this, let's see here, I put this point in. Okay, that point fell right on my line. And I put, oh perfect, I put this point in because that also fell right on my line. You don't have to use data points. Matter of fact, it's probably best not to. I just happen to use those. You don't have to use data points. You can use whatever points you want as long as they fall on the line. This point right here, I could not use because it does not fall on the line. It has to be on the line of best fit. Anyways, I'm going to take those data points, I'm going to plug those into my equation. R equals, okay, so the voltage here is 6 volts, okay, minus 1.5 V. Now I'm going to plug in the currents for those 2 points, 0.0124A minus 0.0032, is that right, A? Yep, that's right. And I come up with a resistance of 489.13 ohms is the resistance. That's also the slope of this graph. Okay. Now, they gave you credit on this if you just took 1 point and plugged it in to this equation. I think that is 100% wrong. They're telling you to use the graph, you better use the line of best fit. Because there are cases, if this hadn't have gone through 0 for some reason, if it's some other graph, and you just assume that you can use 1 data point, it will not be correct, okay? Please, if it says, using your graph, calculate the resistance of the resistor, if it says use your graph, use the graph in a way that is consistent with how we've used graphs all year. I've never let you get away with just taking 1 point. You have to use 2 points on this, okay? It's very, very critical. And it's right, by the way. It's not like the other way, I mean, technically could be right in some cases, but not all. This method will get you the right answer for the slope, if that's what it's kind of leading you towards, every single time. That's the entire Regents. Overall, I thought this Regents was more difficult than the last 2 years, but not nearly as difficult as it could have been. It was kind of like in the middle. And that's pretty much it. I'm glad that I was able to make these series videos. I hope that it's helped you out somehow. Look for other videos that I might be doing. Bye.